Okay, let us start. So if you help a lot, if you can submit one day before. All right, one day before. So do your homework by Friday if you can. All right, if you really cannot, Saturday morning is fine, but at least at least 1 hour before the lesson start at the most. Okay. But do you know I have lesson from 9 o'clock, 9 to 10:30, I have a set one class. So if you submit the word, then sometimes my lesson extends a little bit. All right. Then if I generate the report at 10:45, all right, so I will usually regenerate the report. Okay, let's start. Okay. Now, most of you got this right. If you see green in color, it means it's correct. There's one of you who submitted the wrong answer. All right, just take note. Mass is in kilogram. All right, weight is in Newton. Okay, so the answer is D. This one no need to understand. It's just memory work. Right, SI unit stands for the Standard International. All right, the international unit lah, used by all the scientists in the world. Okay, so for mass, it will be kilogram. For weight is Newton. Okay. Oh, you did it at 7 o'clock. Zeyu, yeah, I have. Let me see. Just a minute. Yeah, Zeyu, I have your name here. Okay. So I regenerated report just before about 20 minutes before lesson start. Usually I'll generate half an hour before the lesson start. Let me admit one more. Jared, and mark the attendance. Jared. Sorry, the person who just came in, can you rename yourself, please? Who has just come in? Can you tell me your name? Can you unmute yourself and tell me your name? Right, if not, I have to do comparison. It's going to waste a lot of time. Okay, or maybe I already marked your attendance. You went out because of internet speed, is it? Okay, let me just read off the names. These students, if you're here, let me know. Chen Chin not here. Harini not here. Zenith not here. Kiran. That means Kiran, you're the one. Okay, I'll mark you present. Okay. So I have marked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14. That is correct. All right, because Bernardo, you log in using 2 devices. Okay, let's continue. Okay, so let's move on. Now let's revise this. Everybody will unmute yourself and tell me the okay, Zeyu is in. Okay, so can we do one by one, or okay, can we make it a little faster? Someone will unmute yourself. Ais, maybe you drew current. Do you know the SI unit for current? Or everybody type into the chat. Maybe that's faster. Okay, Bernardo, good job. The rest, what is the SI unit for current? Okay, good job. So it's ampere. All right, so ampere. Then how about voltage? Everybody type into the chat. Voltage will be volts. All right, so this is ampere. Short form is A. This is volts. Short form is V. How about resistance? Ohm. All right, so it's like that. It's a very nice omega. So this is ohm. Power. Type into the chat, power. This is my mathematics teacher's surname in secondary school. All right, her name is Mrs. Watt. Really, that's her name, you know. So can I thank her for that so that I remember her as a powerful maths teacher. Power, ma. Precious, she's a powerful maths teacher, Mrs. Watt. Right, next, force. Previous MCQ question, force is our scientist, right, who discovered gravity, right? Newton. All right, so Mr. Newton, the scientist Newton, found out there's gravity pulling the apple down. Okay, work done or energy done. You all need to do your homework every week before coming for tutorial lesson. So how much joules of energy do you need to do your homework? Right? How many joules of energy do you need? Okay, so how much work done is in joules. Temperature. Okay, good job, Caitlin. It's around capital K, Kelvin. It's not degrees Celsius. All right, so 0 degrees Celsius will be equals to 273 Kelvin. All right, so yeah, so basically Kelvin is a different scale. All right, length, next, length. Okay, good job, Saron. The rest, what is the SI unit for length? Is meter. How about for mass? Okay, good job, Fernando. Small letter K, small letter G, kilogram. Okay, good job, Caitlin. Time. SI unit for time will be no, okay. This should be easy, right? Second. All right, so just take note. Mass is kilogram, because people will thought it's gram. That's not true. All right, it's kilogram. Okay, so it's typed out nicely here, but then please test yourself. Okay, let's go on. Now, which energy harnessed from the ground? Now, one of you got this. Oh, I know already. Hang on a minute. Now, for this, right, I put a cross. The system marked wrongly. Okay, so for this, right, the answer is, do you realize that it's very strange, right? B is marked red. Then this B, this also B. So there's something wrong with the generated report. I'll highlight to the team. So the answer is harness from the ground is geothermal energy. All right, so what is geothermal energy? Okay, so I have some, I tried to put into one slide for everybody to study. Just a minute, there's something blocking. Okay, now these are the non-renewable sources for energy. So one day, our great-great-great-grandchildren, if you ever get married, you have children, then your children will have their children and so on. Let's say you have great-grandchildren or great-great-great-great-great-grandchildren. Maybe in let's say coal will only last about 100 years. So in about 100 years from now, there will not be any coal left in the ground or left in the sea. All right, so right now we are digging out coal from under the sea and under the ground. Okay, coal is a black color solid. Okay, then crude oil is a black color liquid. Okay, so you have a solid fuel, you have a liquid fuel, and you have a gaseous fuel, gas. So you have solid coal, liquid crude oil, or you can say liquid petroleum. Gas is natural gas. So all these are made from Mother Nature, millions of years of all the dead plants, dead animals being pressed down by high temperature, high pressure. High temperature, high pressure, dead plants, dead animals will be changed to coal, crude oil, and natural gas. Crude oil, another word for it is petroleum. Now, petroleum, everybody type in the chat, is petroleum the same as petrol? Is petroleum the same as petrol? Okay, so answer is no. Petrol is petrol, petroleum is petroleum. All these are mixture. Coal is a mixture, petroleum is a mixture, natural gas is a mixture. All right, everything is a mixture. So petroleum, from petroleum mixture, one of it you will get is petrol. All right, there are many things inside petroleum. Got diesel inside petroleum, got petrol inside petroleum. All right, there's kerosene inside petroleum, many things. Okay, so you will learn more in set 4. Okay, what are the different things inside petroleum? Okay, so these are the 3 fossil fuels after millions of years, changing the dead plants and dead animals. Under high temperature, high pressure, all the dead plants and dead animals change to coal, crude oil, and natural gas. They are all mixture. Then next, we also have nuclear fuel. So some countries, right, when they dig from under the ground or under the ocean, they found a lot of uranium metal. All right, uranium is a radioactive metal. All right, so anyway, crude oil, petroleum, as well as natural gas, they last only another 50 more years. They'll be used up in the world. Coal and uranium, all right? Uranium is an element, coal is a mixture. So coal is a mixture, uranium is an element, crude oil, which is petroleum, is a mixture, natural gas is a mixture. So it only lasts about 50 to 100 years from now. Right, so we should use less electricity. When you use electricity, we are burning all these. Singapore, we burn natural gas. In China, they burn mostly coal. All right, thank goodness Singapore burns natural gas, less pollution. There's less pollution when we burn natural gas in the power station. All right, in China, China start with C, right? They use more of the coal. When you burn coal in the in the power stations, right? When you burn coal in the power stations, a lot of air pollution. Okay, right. Nuclear power station, they use uranium. Okay, it's called uranium-235. Okay, there's many types of uranium atom, but this is a uranium-235 atom. Okay, so one day all these will be used up, non-renewable. Renewable means it will renew itself, it will not be used up. So solar energy comes from the sun, wind energy from the wind, hydroelectric is from moving water. Tidal energy is from the tides. This one is Mother Nature, high tide, low tide. All right, the waves, all right, the waves coming in, the tides, high tide and low tide, that's tidal energy. Whereas hydroelectric is the river water. All right, whereas tides, right, is from the ocean, the sea water. This one river water, this one sea water. Biofuel is from the plants and animals. Geothermal is from the earth's heat. All right, so inside the earth is very, very hot. So we can make full use of the heat from the earth. So geothermal is the, geothermal is actually from the heat from the under the ground. Okay, so let me explain all these power station. This one is solar. Can you see it's solar energy? A lot of solar panels. Okay. Then just something interesting for you to take note. The biggest power station in Singapore is Senoko. So this is Senoko Power Station. This is the biggest nuclear power station in Japan. All right, so Japan has the biggest nuclear power station. All right, nuclear power station, if there's no accident, it's quite okay. Like there's accident, there's a lot of radiation. All right, because uranium is radioactive. Okay. Then this one is the biggest solar power station in India. This is the biggest wind power station using the energy from the wind in China. This is in China. Right, this is the biggest hydroelectric power station in China. All right, so they built a dam, a very huge dam. So they will, the water here will be collected. All right, then later at certain time, they release this water from the river. All right, so this water from the river will turn the turbines. And when the turbines turn in the power station, it will turn the generator and generate electricity. Okay, how geothermal power station works is because under the ground there's hot water, either hot water or hot gas. All right, so we can make use of the hot water. Hot water is pumped from under the ground, so we're using heat from inside the ground. You know, the center of the earth is so hot. All right, so hot until rocks can become melted rocks, liquid rocks. Okay, so hot water will be pumped up and then to become steam. Steam will turn the turbine, and the turbine will turn the generator, and the generator will generate electricity. Okay, so this word grid means the whole system of power lines used to transmit electricity to all our homes. Okay, so this is in the power station, making use of heat from under the ground. All right, so under the ground, inside the ground is very hot. So this is geothermal. Thermal means heat. Geo means inside the land. All right, so inside the earth. So let me put it this way. Geo sounds like geography. If you have studied geography, it's about earthquakes, volcanoes, it's about the earth. All right, so geo means earth. Then thermal means heat. So the earth heats, all right, making full use of the heat from inside the earth. Okay, just now we mentioned biofuel. So I just want to give some introduction to you. There are different types of biofuel. Bio comes from biology, right? That means plants and animals. So we can actually grow corn. We can grow sugar cane to power up our power station. We can use sugar cane to generate electricity. All right, so all these are edible. So it's a little bit of dilemma, right? If we grow sugar cane, or if we grow wheat, okay, do we actually use the wheat as our food, or we use the wheat to generate electricity. So there's this conflict lah when we grow wheat. We use wheat as food, or we use wheat to generate electricity.